Stars in the solar system. So can you define stars? What are stars?
Stars are like the uh, stars are the bodies that are far away from Earth.
Okay, stars are the objects which are far away from the earth. What else?
Uh,
They are the heavenly bodies, right? They have their own light. They twinkle at night. We see the stars at night.
hmm.
Can we start? Are there any stars in the morning hours, the daytime?
No, because there are, but we can't see because of sun like light.
Okay, there are stars even in the morning, but we cannot see the stars in the morning because of sun's light.
Hmm.
Yes. And where do they get light?
Uh,
Stars and the sun, they have their own light, right? They emit light.
hmm.
So where do they get light? From where do they get light?
That's natural.
That's natural. There are certain kind of reaction. There might be certain kind of reactions taking place inside of them,
Mm-hmm.
right? And due to which a large amount of heat is produced,
Mm-hmm.
right?
Yes,
Okay. So do you have what is sun? Is sun a star or a planet?
star.
Sun is also a star. Then why is it big? Other stars are very small in size, point sized, but
Because
sun
sun
appears
is
quite big. Hmm?
because the other stars are more far than the Earth,
Yes,
and
because
sun
other
is
star,
the
sun is the nearest
nearest star
star.
from Earth.
Yes, and it is the only star of a solar system. In our solar system, there is sun and 8 planets which revolve around the sun in specified orbits. Yes. So
Yes.
solar system. Can you name the planets, all the planets in correct order?
Uh, First is Mercury,
Mercury.
Mercury, Venus,
Yes.
Earth,
Right.
Mars,
Hmm.
Jupiter.
Okay. So Jupiter is the biggest planet, right? Largest planet
Yes,
of a solar
yes,
system.
yes.
Mercury is the smallest. Mars is
Hmm.
the red planet. It is also called as red planet.
Because it's the like uh, because it is near to the sun.
Okay. Mars is closer to the sun and that's why it is red in color, or what? Is there any other reason?
Like other reason also. There's other
See,
reason also.
Earth is more closer than Mars, but Earth is not red in color, Earth is blue in color.
Yeah, yeah, because on their surface, like on stars also, they
There
emit
might
like
be
that.
certain type of material in the Mars which makes it red color, right? Red in color, right?
Yes,
And there are rings around Saturn also. Rings of gases around Saturn we can see.
yes.
Okay. So what is universe? How can we define universe?
Uh,
It is the surrounding space, vast surrounding space, having all heavenly bodies like stars, planets, comets, meteors, everything in it. It consists of everything. So what else you know about universe? What are galaxies?
Galaxies are like Milky Way
Milky Way
galaxy like
is our galaxy where we
galaxy.
live in. Yes. So how many
Uh,
galaxies are there in the universe? Any idea?
I don't know.
You don't know. There are so many galaxies in the universe. It's around 10 raised to the power 11. 10 raised to the power 11 galaxies in the universe. So astronomy is the branch of science that deals with the study of planets, stars, and the heavenly bodies. Okay. So as we study science, as we study social studies, maths, English, Hindi, as we have other subjects. In the same way, astronomy is a subject where we study stars, where we study planets, where we talk about heavenly objects. Okay?
Hmm.
Yes?
Yes.
Celestial bodies are the heavenly bodies that are part of the universe and are also known as celestial bodies. These are the heavenly bodies. So, all the objects which make up the universe are the heavenly bodies, which are present in the universe are the heavenly bodies or celestial bodies. Okay?
Hmm.
Any doubt in this?
No.
And stars are also celestial bodies because they're present in the universe and they give out the light and the heat. Okay? And where do they get this light and heat from? Because of reactions
Uh,
taking place inside of
nuclear
them. They are
reactions.
nuclear reactions.
Hmm.
Hydrogen atoms combine and they form helium, and large amount of tremendous amount of energy is released during these nuclear fusion reactions, and they get this energy from those reactions only.
Hmm.
Light year. So is the this what is this light year? Any idea? Can you define light year
Uh,
in your own terms? When you think about
uh,
light year, what do you feel that this should be the light definition of
yeah,
light
it's a
year?
speed or distance like that.
Yes, it is
Speed,
distance,
distance,
speed or distance.
like
Why not time? We have
distance.
year in time, light year.
Uh-huh.
Then, right? You're getting confused. It's very easy, ना?
Hmm.
आपको confuse करना कितना easy. Agree मत करो, सोचो. Light year is the unit of distance. You were right. Okay, fine. If we take light year as the unit of distance, then how should we define light year?
Uh, light
Light
year
year. It is the unit
is
of distance, yeah? Right? It is
yes.
the unit of distance. How should we define a unit of distance which is light year? If we say light year is the unit of distance, then how will we define it? Distance traveled by light in 1 year.
Hmm.
What is light year?
Distance traveled by light in 1 year.
Yes, it is the distance traveled by light in 1 year. So how do we find distance? What is the formula of distance? If we know the speed and the time, we can find distance.
Hmm.
What is the formula? How are these three quantities related?
We need to find distance.
If you have the speed and the time, then how will you find distance?
Speed multiplied by time is equals to distance.
Yes. So we know the time, right? It's 1 year.
Hmm.
Time is
One
one
year.
year. And what is the speed of light in vacuum or in space?
Uh,
Any idea? It's 3 into 10 raised to the power 8 meter per second. So we know the speed of light. We know the time, it's 1 year. So we can multiply the quantities and get the distance. Yes?
hmm.
So speed of light is 3 into 10 raised to the power 8 meter per second. See, in 1 second, light can travel a distance of 3 into 10 raised to the power 8 meters. So after 3, if we put 8 zeros and then meter, this much distance, light can travel in just 1 second. In just 1 second. Okay. And time is 1 year. In 1 year, how many seconds do we have? See, we are converting all these terms in SI units. Okay. SI unit of speed is meter per second and SI unit of time is seconds. So in 1 year, how many days do we have?
365.
We can take 365. Actually, it is 365 one by 4. 1/4 of a day we can add if you want. Okay, let's take 365. In a day, we have 24 hours.
Yes.
And in 1 hour, we have 60 minutes.
Hmm.
In 1 minute, we have 60 seconds. So when you multiply all four, then you get 1 year in seconds. Okay? It is a simple unitary method that we have been doing from lower classes. Okay?
Okay.
If I say how many seconds are there in 1 minute, you say 60, right? In 2 minutes, it's 120. It's as simple as that. Okay, so 1 year can be converted into seconds like this. So 365 days, in 1 day we have 24 hours. Look at the cursor. In 1 hour we have 60 minutes. In 1 minute we have 60 seconds. On multiplying all these quantities, we get year in seconds. Now, because distance is speed into time, you will simply multiply these two to get the value of distance. Okay, and it is 9.46 into 10 power 15 meter. Please write this.
Power 15 meter.
Lavansh, when you go by bus or by train, when you travel by bus or by train, you find trees and everything moving in backward direction, right? They appear to be moving in backward direction. Though they don't move, they are still. Trees are at their position only. Platform is at its position only. It is not moving at all. But when you move by a train, then you find platform to be moving in backward direction because you are moving in forward direction. So this is relative motion, relativity. Okay. So when we move in forward direction, we find other things
Moving in
moving
backward
in backward.
direction.
Though they are not moving, they are at their position because we are moving. So other things appear to be moving. Right? So similarly, because Earth rotates about its axis from west to east, all heavenly bodies appear to move from east to west across the sky because of this. Because when Earth rotates about its axis like this, from west to east, yes, so everything, sun, stars, and other heavenly objects, they appear to be moving in east to west direction. Okay. So this is called apparent movement. Apparent movement means movement which is not real, which is not actual movement, which is not real movement, but it appears as they are moving. We see sun rises in the east and sets in the west. Every day sun rises from the east and sets in the west, right?
Even sun is not moving.
It moves at its own position. Right. Actually, you have you ever read about Big Bang Theory? Universe is expanding and all the stars and everything, their relative distances, it keeps on increasing. Yes. So everything is moving with respect to other object. As we can take an example, suppose we are sitting in the room, so I find you at rest. But if I observe you from the moon, then
I'm moving.
Then you are moving with respect to me because Earth rotates about its axis and I am observing you from the surface of moon and Earth is rotating and you are also moving along with the Earth. Okay. In the same way, because Earth rotates about its axis from west to east, so we find all the heavenly objects moving from east to west. So they appear to move from east to west across the sky. This is called apparent movement of stars. Okay. Pole star, next topic. Pole star, North Star, Dhruv Tara, Polaris. So what is this Dhruv Tara? Have you ever seen in the sky a Dhruv Tara?
Dhruv Tara.
See, we see stars moving, na? Their positions with respect to us, it keeps on changing, right? But there is one star which appears to be fixed in the sky, and that star is Dhruv Tara, and it is also called North Star or Pole Star. Okay, so all stars except the pole star appear to move from east to west? Because Earth rotates from west to east. So stars appear to move from east to west. Okay. This is because the pole star lies exactly on the axis of rotation of Earth and hence appears to be fixed. Okay. In fact, all stars appear to move around the pole star. See, if I rotate the Earth, then
Then the star will move to opposite direction, and the one star in the north will not change its position.
yes,
It will remain there.
because it lies on the axis of rotation. And what is the axis of rotation here?
East to west.
See, this axis.
Okay. There's
If you look at
no.
this globe, if you look at this globe, and because we are, you can see, I'm moving this globe like this. Okay. So for this globe, axis of rotation is, look at this stick. It is
Yes.
rotating about this axis, no? Wait. This point is fixed. This axis is fixed. Can you see this?
Yes.
So this is the axis of rotation. It is rotating about this axis. So pole
Like
star lies
uh,
exactly on the axis of rotation. Okay. Pole star lies exactly on the axis of rotation. So it appears to be fixed, while other stars which do not lie on the axis of rotation, they are somewhere else. Because Earth is rotating like this, so they appear to be moving in this direction. If Earth is moving in this direction, then stars appear to be moving in a opposite direction. This is apparent movement of stars. But pole star appears to be fixed because it lies on the axis of rotation. Clear?
yes.
भूलोगे तो नहीं?
No.
Good. Sun. So sun is the nearest star to the Earth. What else you know about sun? It gives us light.
Yes, and it's and it is also called a fireball.
Okay, fireball. Okay,
And
what else?
uh,
In India, we pray the sun. We treat sun as a
God.
god. And
And
what else? It gives us light, it gives us heat, it is the nearest star. What else? It helps in photosynthesis. Without sunlight,
there's no photosynthesis because
yes,
plants need sunlight
yes,
to make their food.
yes. Plants need sunlight to make their food. And we get energy from sun
Uh,
and we use the
yes,
solar energy. Solar cells we use these days. Solar panels, we fix
yes,
solar panels on our roofs.
yes.
So sun is the source of heat and light for all the planets in our solar system. It is the source of all energy on the earth and it is the ultimate source of all energy. Ultimate source means
Ultimate, like
all other energy types, all other energy sources have been evolved from sun's energy only. See, we get food energy, right? We get food from plants and plants make their food because of sunlight. If there is no sun, there would not be any photosynthesis process and there would not be any food and we won't get food. And in that case, we won't get food energy or chemical energy, right? Sun is the nearest star and it is the only star of our solar system. On the other hand, Alpha Centauri, it is the second nearest star to the Earth. After the sun, we have Alpha Centauri. Okay? Yes?
yes.
Sometimes, they ask this question in the exam. Name the nearest star other than sun. So it's